Welcome to Educational Village channel and welcome to A-Level Chemistry. In this video, I will be discussing the formation of intermolecular forces. Intermolecular forces, forces of attractions between molecules, weaker than covalent and ionic bonds. The forces are responsible for the physical properties of substances, such as boiling point, melting point, solubility. There are four main types of intermolecular forces: van der Waals forces, permanent dipole-dipole interactions, hydrogen bonds, ion dipole interactions. Van der Waals forces are the weakest and temporally present in all molecules. Here is an explanation of formation of van der Waals forces. Electrons orbit in electron shells. At any given time, one side of a molecule may have more electrons than the other side, creating temporary dipoles. This temporary dipole can induce dipoles in neighboring molecules. Electrostatic attraction between opposite poles of neighboring molecules are attracted. Formation of van der Waals forces. Permanent dipole-dipole interactions present between polar molecules. An explanation of formation of permanent dipole-dipole interactions: the molecules become polarized when there is an unequal distribution of electrons between atoms. Here is an example of permanent dipole-dipole interactions. In the hydrogen chloride molecule, chlorine is more electronegative than hydrogen. Therefore, chlorine acquires partially negative charge while hydrogen acquires partially positive charge. Then the opposite poles of neighboring molecules attracts each other, resulting permanent dipole-dipole interactions. Another type of intermolecular force is the hydrogen bond. Hydrogen bond is the strongest of all intermolecular forces. They occur when hydrogen atom is covalently bonded to highly electronegative atoms, such as fluorine, oxygen, nitrogen. This causes hydrogen atom gains partially positive charge and an electronegative atom gains partially negative charge. The electronegative atoms must also have long pair of electrons. This creates an attraction between partially positive hydrogen atom in one molecule and the long pair of electrons on the electronegative atom of another molecule. I would like to discuss the key points of drawing hydrogen bonds. Show partial positive on hydrogen atom and partially negative charge on electronegative atom. Include the long pair on electronegative atom and use a dashed or dotted line from long pair of electronegative atom to partially positive hydrogen in neighboring molecule. Bond angle between hydrogen bond donor and acceptor atom should be about 180. The next type of intermolecular force is ion dipole interactions. Ion dipole interactions occur between ions and polar molecules. When an ionic compound dissolves in a solvent like water, the process of ion separation. Each anion is surrounded by water molecules. Attractions between anion and partially positive end of water molecules. Similarly, each cation is surrounded by water molecules. Attraction between cation and partially negative end of the water molecules form ion dipole interactions. I will use sodium chloride as an example to discuss the formation of ion dipole interactions. The positively charged sodium ion is surrounded by water molecules. Attractions occur between sodium cation and a partially negative oxygen atoms of water molecules. Similarly, a chloride ion is surrounded by polar water molecules. An attraction between the chloride anion and the partially positive hydrogen atoms of the water molecules form ion dipole interactions. Thank you so much for watching. If you found this video helpful,